In this video, we're going to modify the part we created from problem 3-9 in your book to update using equations so that the sides and dimensions are related to one base dimension instead of being independently defined. So take a look in your book at problem 5-7. It shows us the standard geometry from our problem 3-9, and now it says instead of using the individually defined dimensions like we have here for 120 being the width and 70 being the height, or the depth, vice versa. They're talking about, looks like this way they have width of 120 and they're talking about 70 as the depth. So they want the depth to be 1/2 of the width plus 10 millimeters. And you can see right now it's that, but it's defined as that. So if we change this to 130, that 170 is not going to change. So we want to use an equation to change that. So we double click on the one we want to change, say equal to, because that's how we started an equation, equal to this one divided by 2 plus 10. Okay, and you can see it's 70, but now has the sum symbol in front of it. So we've got that one updated. The other thing we're supposed to update is the height of the fins. So right now, if we look at the fin height, that's defined in this feature here, it's set at 40 millimeters. And we're supposed to set that so it's equal to the width of the part divided by 6 millimeters. Okay, so the width of the part, let's see if I can get that to show up. I can't while I'm in the feature definition, so I'm going to go back out of it and look at that sketch so that I can find the name of this dimension. So this dimension's name, you see there's D2 at sketch 1. You can also get that by copying it right here. There we go, D2 at sketch 1. Okay, while I have that name, then I'm going to rebuild and go back to the feature definition. And I can start, that's the wrong one, this is the right one. So equals dimension name, and I have to put the quote marks around it so that it knows that that's a dimension. It's equal to that divided by 3. Okay. So now that one updates, and the last one, or actually not the last one, the next one is that the number of the fins equals the width divided by 6 millimeters. So that would be in this sketch here where I defined this pattern. So there, that 20 there, that's the number of fins, so that's going to be equal to, and again it's that sketch 1 dimension divided by 6 millimeters. Oops, that's times. Okay, so we've got that one in as an equation. And the last one is that this distance here is supposed to update so it's always equal on each side, so that basically the fins are centered on the base plate. So right now it's centered at 1.5. Let's figure out an equation that can adjust that. So be equal to the full width, so that was D2 at sketch 1. So it's going to be equal to that full width minus, let's see, minus the number of fins, which that's this one, times the width of the fins, that's 6 millimeters. So get that answer, all of that, and divide it in half. Okay, let's look at that. Let's see if that worked. Oh, I missed the divide sign there. And you'll notice I put those parentheses in there to make sure that the order of operations happens correctly. Okay, looks like I missed the width of one fin in that calculation, so I need to add in there plus 3 millimeters for that one fin that doesn't have a double. Okay, so now that looks like it's updating correctly. So let's go back and just plug in some different values and see if they all update as we would want. Let's rebuild this. Okay, so here's our original version. And now let's change this to be 200. Yeah, it looks like it's scaled the width, which is supposed to be half of this plus 10, so that'd be 110. That's great. Let's actually change this to 220. I'll make the next calculation, or 210. Let's do 210. Okay, so half of that would be 105 plus 10, that gets us 115, and then the height of the fins are supposed to be a third of this base height, so that should be 70. Let's see if that's what we got. Yep, 70 millimeters, so that part looks good, and they are centered fine. So let's check that centering with a few other numbers. Let's just pick some weird ones. Let's try 125. So yeah, it's still centered correctly there. Let's see if we go down to 90, what happens. Yep, so it all looks like it's scaling well. And so I think that's everything we needed to do. Oh, it says to make sure they work correctly from values of 60 to 180. So let's try 60. That looks fine. And then 180. That looks fine as well. So I think we've completed everything for problem 5-7. I hope that's helpful. Just, I guess, before I go, always remember we can go back and look at all of our equations by going to Manage Equations, and we could edit them or verify that they're working correctly here.